Let's say there is set A which contains 1, 2, 3, okay. Now if I ask you, is this a subset of A?
Yes.
Or this an element of A?
Element. It's an element.
It's an element.
Yes.
This is not correct. However, this is correct. A set containing, the set containing 3, that is a subset. Just the set containing 3 is an element. Please be very careful about this, because a question may come, in fact it can come in a JEE exam also. I've seen people misusing the notation of subset and belongs to. Are you getting the point? So if I say, this is belongs to A or is a subset of A?
Subset.
It's a subset of A. Are you getting this point? So please be careful about it. Write down a question on subsets. There are two sets A and B. There are two sets A and B. With finite number of elements. With finite number of elements. There are two sets A and B with finite number of elements. Okay. The number of subsets of A. The number of subsets of A is 56 more than the number of subsets of B.
56.
Yeah.
Yeah.
Find the number of elements in set A and set B.
Yes.
Shut up. 5.
I know.
So we can do hit and trial always, right?
I'll do it by logic also.
It won't take time.
3 and 6.
Very short.
Okay. So basically, there is a set A and set B. Set A and set B. Let's say A has n elements. You can call it as m elements.
So what are we supposed to find?
Yeah, it is given that the number of elements in set, number of subsets of set A is 56 more than the number of subsets of B. Find the number of, or find the cardinal number of set A and set B.
Sir, through logic.
So you can't do the logic.
Yeah.
2 power n minus 7, then you take a common, then you solve it.
Yeah, 2 power n minus 2.
Yeah. We did it in class.
Yeah, we need it in class.
Exactly 56.
Oh yeah, good point.
Given the formula for
Yeah, we did this.
Yeah, we did this. Yeah.
The answer is 6 and 3. Okay.
Show us the logic.
Logic, I'll show the logic. So 2 to the power, number of subsets of this set is 2 to the power m. The number of subsets of this is 2 to the power n. Now it is given that the number of subsets of A is 56 more than the number of subsets of B. So 2 to the power m is 2 to the power m plus 56. So 2 to the power m minus 2 to the power n is 56.
Yeah.
You clearly know n and m are natural numbers because they are finite sets. And m is greater than n. So I can clearly take out 2 to the power n common.
2 power n.
That would leave me with this. Okay.
So only
Now, now we have to break 56 into two factors. One being a power of 2 and another being an odd number.
Yeah.
Correct? Now, can I break it as 1 into 56? No, because 56 is not a power of 2. Can I break it as 2 into 28? No, both are even. Can I break it as 4 into 14?
Same reason as the last.
14 is not an odd number. 2 is a power of 2, but 14 is not a power. So the only possibility is you can break it as 8 into 7. Right? So when you break it as 8 into 7 means this is 8. You can call it as a hit and trial, but you can just find out cases as well. So n is 3. So 2 to the power m minus 3 minus 1 is 7 means 2 to the power m minus 3 is going to be 8. 8 is 2 to the power 3 again, which is m minus 3 is 3, so m is equal to 6. Okay?
Ma'am,
Yes. Any question?
so we could just basically say that we have point of cars of two that are just separated by
Yes. Simple. Now coming to power set. Shaban is becoming thinner day by day.
and I'm ciphering fat from
Can I resist? Advait? Alright. So what's the power set? Power set of a set is represented first of all by this. Some books you realize they mention it like this. Okay.
What?
Power set of a set A is represented with a P with A in brackets, or sometimes they write it as 2 to the power A. Right?
Using your hand.
It's not 2 to the power NA, it is 2 to the power A. It's a symbol. So it represents power set of A.
So like a handy thing just to say ask the cardinal.
Yes, yes. Now, what is power set of a set A? It's basically a set containing all elements X such that X is a... Is that okay? So I'll give you an example. Let's say set A has 1, 2. As I took the previous example, then power set of A would be a set containing null set, set having 1, set having 2, set having 1 and 2.
Oh, so in the previous example, X itself is a set. It's not an element.
X itself is a set,
Yeah.
and that is a subset of A. So the elements of a power set themselves are sets. Correct? And those sets are basically the subsets derived from A. Are you getting it? Yes or no? Okay. Now I have a question for you all. How many elements are there in the power set of a set? 2 to the power the cardinal number of the set whose power set you are finding.
A power of power set.
So the cardinality of a power set of A is 2 to the power NA. Okay. A small problem I would like you to solve. Tell me the power set of the power set of the power set of a null set.
Some what is going on? So it will be the 2 to...
Write it down.
No, 8 to the power of N. That's all, right? 1.
I'm not asking you the number of elements in this. I'm asking you to list down the power set of the power set of a 5.
Sir, 5 only 1. It will be 5 only. It will be 1 element.
No. So basically that's just 5. Then I have 5 and
Sir, 8 then. It's 1 or 8? It's only 5.
Power set of a null set will have how many elements?
1. Yeah, so 1 is 5 brackets.
2 to the power 2 is 4. 4 elements.
So what are they?
That's what I'm asking you.
So how do we do it? Oh wait, so 5 is an element and there is another 5. So 8. So 8 are there.
So I just want you to see, I want to see you try.
Sir, 8. He wants to know the elements too.
I want to know the elements in the power set of a power set of a power set of 5.
Yeah, so 8.
Asking which one is it?
Write it down, write it down. You have to
It's 8.
write it down. Should I erase this part at least?
what are the elements? Okay, power set.
Please list down the elements in the power set of a power set of a power set of 5.
Oh, wait, got it.
Ved, Ashish, absent.
Oh, Oh, sorry, is it 16?
16.
It's 8 only. Or 8 only.
Got it. Oh, okay, got it.
Oh, wait, it's 2 out of 2. Okay, so wait, this will be.
Sir, got it.
Got it, sir. Wait, I got only 6.
Sir, I got 4.
Oh, 4. Yes, sir, I got 4. Yes.
Yes, it's 5.
Yeah. Yes.
5 in brackets.
Yes.
5 in double bracket. Okay, 5
in
bracket.
brackets.
5 brackets.
5 in double brackets. Yes, sir, got it. Sir, got it.
Sir, is that correct?
Shh. Girls there.
Sir,
Ananya. Nanika.
This one.
Neha. Khushi. Huh? Is 5 not an element? It can be.
Sir, 5 in brackets, 5 in double brackets.
There is set 5. 5 is a set. We just now saw null set is a set.
Comma.
I am finding the power set of that. A set can be an element also. Little while ago I told you. An empty set can be an element. Let's say, okay, it's a null set. It's a null set, but it's an element in itself. Huh? 5 is a null set. 5 is a null set, guys and girls. 5 is a null set, agreed? Yeah. Now, one simple question I want to ask you. If I have a set which is 5, how many subsets can you make out of it? One, that is the set itself, that is 5. Correct? So the subsets of this is just 5. So if I ask you what is the power set of 5, you will say a set containing an element which is 5. Are you getting it? Now many people think that a set with 5 is as good as 5. No. An empty box is not equivalent to an empty box within an empty box. Right? Yes or no?
Empty box is filled with another empty box.
Now, let's say I have this set now. I have a set having an empty set as an element in it. What are the subset of this? First of all, null set and the set itself. Both are different now. Don't think that this and this are same things and you are writing the same thing twice. No. This and this are different. So if I form a power set of a null set, it will be a set containing 5 and another element which is also a set containing 5 as the element. Correct?
Yes, got it.
Now if I ask you, I have a set which contains these two elements. Tell me its subset. What will you say? Null set. A set containing 5. A set containing the set containing 5. And then a set containing 5 in the null set itself. Correct? So what is the power set of a power set of a power set of a null set? It will be a set containing null set, a set with 5, a set with a set having 5, and a set with 5 and a set with 5.
Oh my God.
So 4 elements, 1, 2, 3, 4. Okay. So the cardinal value of this is going to be
4. Sir, compiler. It's perfect.
compiler. Okay.
What's the power set of this?
Compiler.
Okay. Is that okay? Understood? This example was actually my means to tell you that a set with a null set and a null set, they are not the same. An empty box is different from A cupboard containing an empty box.
Yeah.
Correct? Is that
So one second.
one is addition or one is skills in maths? Skills in maths. Can I erase this? Sets become very important in fuzzy logic. Fuzzy logic. If you take computer science and you'll be studying fuzzy logic in IITs. Fuzzy logic.
What is fuzzy logic?
It's a discrete maths actually.
Whoa.
Dealing with sets.
Oh yeah, that's quite tough.
Can I erase this? What is there? Just two important properties of power set. Power set of A intersection with power set of B is equal to power set of A intersection B. Okay.
So will we be proving all of these?
No. We will not take. We are only taking proofs which are very important.
Even school they don't have proof.
They will ask, but not these levels. Okay. However, power set of A union power set of B is a subset of power set of A union B.
Because you don't have A union B itself in it.
Wait, let me take something.
You don't have you don't have A union B itself in it.
Intersection of
Suppose if there's one element X that's not in A, that's in A but not in B, you won't have A union B contains the X.
Is it okay? Please note this down. I will stop there where it is very important for us to prove things. As of now, we can move on to the operation on sets. That's very important. So we are now going to learn some operation on sets.
I thought it says.
P is power set of A. Yes. I'm sorry, did I erase it? What is it? Operation on sets is something which you have already run. I'm just quickly recapping it. And I will be explaining the operations through something called Venn diagram. Right? Venn diagram is basically a pictorial representation of sets which was jointly found out by Euler and John Venn. Okay. Euler's contribution is huge in maths.
Yeah.
As soon as he starts with complex number,
E power 5 pi is equal to.
that's the most beautiful equation.
Yeah.
E to the power I pi plus 1 equal to 0.
Yeah,
The
how
most
did he
beautiful
do that?
equation in maths.
Sir, how do you do something to the power of 5? I don't know.
How did
We'll take up in complex number.
how did he come up with
How did you even go?
I tell you the proof for that. Okay.
It is so good, dude.
Alright, operations on sets. First is the union. Union of two sets. Represented by A cup B or A join B. Many books will also represent it as plus. Okay. How it is represented in the set builder form as a collection of all X such that X belongs to A or X belongs to B. Please keep this in mind because this will be forming a very important part in our proving problems also. How are you proving in school? Are you taking an arbitrary element?
Yeah.
Okay, that type of proof is very important. In some schools they say prove it by using the laws of the sets or the properties of the sets.
Sir, we have few some
No, but it's also, it doesn't matter, right? We can
prove anything. Yeah, you can prove anything.
You can prove anything.
But except for Venn diagram, I guess.
Yeah, you can.
Venn diagram should be used to support it. Should not be used as a only means to prove
So
it.
some questions are quite obvious.
So few sums are.
And it becomes very unobvious when you prove it through the laws of sets.
Yeah.
This entire region, shaded region, represents A union B. Is that okay? Next is called intersection of sets.
So only in few problems you have to use properties of sets to solve. Others not you have to take arbitrary.
But when it becomes complicated, that arbitrary element proof fails. It will run into pages. So we'll take up some of the proofs through laws of sets. Intersection of set is represented symbolically as this. And the set builder form, it is written as a collection of all x such that x belongs to A and x belongs to B. Please note the use of the word or here and here. Through a Venn diagram. Achha, one important thing I forgot. Universal set.
Now we know it's a
What's a universal set?
It's a superset of all sets
In the problem.
in the context.
In the given context of the problem. What is a universal set?
Set of all.
A universal set is a set whose all sets in the question are the subset of that set. Correct? Or you can say it's a superset of all the sets in the context of the problem. Why in the context of the problem? If I say there is a set A containing 1, 2, 3, there is a set containing 2, 3, 4, 5, and there is a set containing 4, 5, 6. And if I ask you, tell me a universal set for it, it is just sufficient to write it like 1, 2, 3, 4, 5, 6. Is that okay? This is very important because on the basis of universal set, we find something called complement of a set that I will be discussing in some time with you. Please note, I have seen people, they make any set they want. So, set of all natural numbers. Not required. Only the set which has the elements which are there in all these given sets.
So, but that's
How universal set.
That's not wrong, right? Set of all natural.
But then the concept of complement of a set would be varied. Correct? Are you getting the point? So either you should have a universal set defined, or if I ask you suggest me a universal set, then only include 1, 2, 3, 4, 5, 6.
So it should be as small as possible.
Yes, sufficient. If everybody starts defining their own universal set, I will have different answers for complement of a set, isn't it? Right? So either universal set should be defined by the person who is giving you the problem, or if you have to choose a universal set, it should only contain those elements which are in the sets given to you in the problem. With respect to intersection of two sets, we call two sets A and B disjoint if their intersection is a null set. This is called disjoint sets. Okay? Let me ask you this question and let me see who is able to answer this. There is a set, let's say called C, which has got n elements, A1, A2, da 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 till n. Okay? Okay? How many pair of disjoint sets you can make from set C?
Subsets. Disjoint.
How many, yeah, of course. How many pair of disjoint subsets can you make from set C?
Okay, so you have to take possibilities. So 1 minute. Either X.
How many pair of disjoint subsets can you make from
Sir, 2 to 3 minutes. 2 to 3 minutes.
Sure, take 5 minutes.
It's not doing
It's not like that.
How will it be in this?
something.
Wait, there should be disjoint.
How many pairs of disjoint sets can you make from the set C?
Is it 3 to the power of n?
You're very close.
Ah,
What will you answer?
3 power of n. 3 power of n.
Generally,
Sir, how close?
Very close.
So is it 2 to power n
You
minus?
just have to do some fine tuning.
Is it 2 to power n minus n?
Oh wait, wait.
When you say pairs, means this and this are same. So
Is it 2 to the power?
Oh, so wait. So it'll be.
begin the whole thing divided by 2
Okay.
you are very close now.
plus 1.
So 3 power of n, 3 power of n plus 1 by 2.
Brilliant. Sukrit, come and explain now.
Sir, is it 2 to the power n?
The answer is 3 to the power n plus 1 by 2. Explain it clearly, okay, by how do you make... You're right, okay. You are Sukrit or Sukrit? Sukrit. You are Sukrit or Sukrit?
SUKWR.
Sukrit.
Sukir.
Sukrit.
No. Okay, fine. So you have.
Guys and girls, so Sukrit is explaining this question.
Okay. So now you have n elements over here from 1 to n. Okay, fine. So now let the disjoint sets be A and B. Okay. Let the disjoint sets be A and B. Now say X is an element of C. Okay. Let's say just X is an element of C. Now there are 4 possibilities now. Now I'll just take set A, set B. 1 minute. I'll just finish this. So now there are 4 possibilities. Yes. So now either X can belong to A, X can belong to B, or X cannot belong to A, but X can belong to B, or X belongs to A, not belongs to B, or it doesn't belong to any subset.
Okay, and
So now, yeah, and like he was also close to it, he also gave a symbol. Now they told that it's disjoint sets. Disjoint meaning the intersection is 5. So there's no common element between A and B. So you have to eliminate this option because here it tells that X is an element of A as well as B. That's not possible because the intersection is 5. There's no intersection. So you have to rule out this option. Yeah. So now, fine. So now there are 3 cases. So
for every element there is 3 cases.
yeah, for every element there is 3 cases. So you take this element, it can be this, this, or this. So it will just be every time. So wait, what did I do? 3. Wait, how did I get 3 power of n?
No. For every element we have 3 choices. So for every element you have
That's
3
3
choices. So it's similar to how we founded a power set. Instead of 2 choices, you have 3 choices this time.
Okay, so
For power set we had only 2 choices. We did 2 power of n. Here you have 3 choices. So it will just be 3 power of n.
so every element A1, A2, A3 till AN will have 3 choices. Either to belong to A and not to B, belong to B, not to A, and not to belong to any sets. Correct? That's what he has written by stating these 3 conditions. So 3 into 3 into 3 into 3 to the power n. So 3 to the power n. Now, here's a catch. Why is not the complete answer?
Okay, fine. So now
There is a case where this null set is coming, where you don't choose anything at all. Right? What is going to happen? Then we are over counting the situation, right? So basically, that one case is not going to be counted as 2 cases. Because null set and null set and null set and null set, you are unnecessarily counting it as into both the categories, right? So subtract that case, divide by 2, then it comes to know how many order pairs are being made by 2. Because let's say you have a subset x1 and x2. Now this becomes x2 and this becomes x1, they will be counted as the same thing. Because we just want to have 2 paired set. Their order doesn't make a different combination, right? So by 2. But ultimately you have to add that one case where both of them are null sets. Correct? The pairing will not happen with the null set, it will happen with rest all other sets, and separately I added that one null set pair. Are you getting the point? So basically what I am doing, I am having x1, x2 as all the different ones, but when they become null and null, you cannot have two pairs out of it arising, right? You can have two pairs from each of these categories.